Hello. Yes. We welcome you back to PSSB, Physical Sciences. Silver Plate with me, Richard here. Today we're looking at this question. It says that the diagram below shows one of the cells used in the CHLOR-ALKALINE industry. So this is the setup we have. We're having all these spouts indicating the entries. And then the question comes. It says that write the chemical name and the chemical formula of each below. Okay, the first one is A. Okay, how do we tell what A is? Okay, in order to start with identifying what we have here, we need to look at the polarities. We know this is positive, indicating anode, and this is negative, indicating cathode. So in the CHLOR-ALKALINE setting of the cell, what enters on the anode side is concentrated sodium chloride. Okay, then we come to this one. What comes out on this anode side? It is a spent sodium chloride. Okay, then we come to C. C is on the cathode side and it shows entry. So what enters on the cathode side of the setup? It's water. So C represents water. Then we come to D. D is on the cathode side and it shows out. Okay. So what comes out of the cathode side? It is sodium hydroxide. Then we come to P. P is coming out on the anode side. So what is P? P is chlorine gas coming from sodium chloride. So when sodium chloride enters here, it splits, and one of the product of that splitting is chlorine, which we get as gas P. Then we come to Q. Q is on the cathode side and it's moving out. So what is Q? Q is hydrogen gas, formed as a result of the composition of water. So when water enters here, it ionizes. It's reduced actually to give hydrogen as one of the byproducts. Then we come to this question. It says that write the type of cell above. Okay, they say write electrolytic or galvanic. So what type of cell is this one? Okay, how do you identify this cell? Okay, the moment you have a positive here and a negative here, it implies that you have a battery connected to this cell, implying that the conversion or the energy conversion which takes place inside the cell is electrical to chemical, meaning the cell is electrolytic. Then we come to this question. It says that write the name of the cell above. So what's the name of the cell? Okay, this cell is called membrane cell. given the name simply because it uses a selectively permeable membrane here. So the name is membrane cell. Yeah, then we come to this question. It says, name other two cells which can be used in chlor-alkaline process and give the shortcoming of each. Okay? Yes, we have seen this cell. We said it's membrane cell. Yes, in addition to membrane cell, which other two cells can we use in this chlor-alkaline industry? Okay, the first one is Mercury cell. Yes. And what are the shortcomings of Mercury cell? Mercury is poisonous. It affects the nervous system badly. Yeah, so that is that. Then another cell is called diaphragm cell. Diaphragm uses asbestos. And asbestos is also poisonous. It causes lung issues, which we call asbestosis. So you cough to your death. Yeah, that is that. So these two shortcomings explains the reason why membrane cell is the cell of preference. It doesn't produce poisonous substance, so it's environmentally better compared to these two. Yeah, then we come to this question. It says that give any three advantages of the cell above over others in chlor-alkaline industry. Okay, we said this cell is membrane cell. And we saw that if we don't use membrane cell, we can use Mercury cell or diaphragm cell. So the question is, what are the advantages of membrane cell over diaphragm and Mercury? Okay, the first advantage is that a membrane cell uses less energy compared to the other two. Yeah, the other advantage is that a membrane cell produces less toxic material or less poisonous material. We saw that membrane cell does not use mercury and does not use asbestos, which are implicated in health issues. So, what do we say here? It produces less pollution compared to others. Yeah, then lastly, the products produced by membrane cell are of high purity compared to the product produced by other cells. Yeah, so we come to this question. It says that write half reaction at anode. So this is the positive, our anode. And what reaction occurs at anode? Okay, we need to know that what enters here, we said it's sodium chloride. So when it reaches here, what happens? What happens is that sodium chloride splits into sodium ions, which is here. It's the one which crosses here. And chloride ions here. So you have to know that the reaction which takes place at anode is oxidation. So chloride ions undergo oxidation, and the reaction is of this nature. You have the chloride ion, and they are oxidized to chlorine gas. At this stage, what do? We balance. And after balancing, there are 2 electrons involved here. And what do? You put them here. And that's the reaction which takes place. Where this one is gaseous and this one is aqueous. So now they want half reaction taking place at cathode. So what do we see? We are seeing that sodium ions, actually these are sodium ions, going to cathode. But we are also seeing water entering cathode. So what happens to water? Water is preferentially reduced. So it's going to break down, taking up 2 electrons to break down into hydrogen gas plus hydroxide. Okay? So this is the reaction taking place at cathode. So what are you having here? You're having 2 water molecules are taking up 2 electrons to give you hydrogen gas plus hydroxide ions. And we put a 2 here for balancing. Yeah, so we come to this question. It says that write the net reaction taking place in the cell above. So to answer this question, you need to have the 2 half reactions. And what did we say? We said that at the anode, chloride ions were oxidized to chlorine, and we have the 2 electrons here. So this is the reaction we know, which took place at anode. And we say that cathode, what we have? We have water undergoing reduction to give you hydrogen gas plus 2 hydroxide ions. So what do we do here? When you add these 2 reactions, what you get is going to be the net. So in this case, you cancel out these electrons, and what remains behind is going to be 2 chloride plus 2 water, giving you chlorine gas plus hydrogen gas plus hydroxide ions. So what you have here is the net reaction. And we advise that after getting net reaction, you can cross out this one like this, so that it might not be confused with net. Yeah, then we come to this question. It says that from the diagram above, identify the 3 products formed from the cell. They say write letter A, B, C, D, P, Q, and the chemical name. So which of all these are products? Okay, how do we identify products? Okay, first of all, the product must be going out. So we have this one. P is a product, Q is a product, and D is a product. Those are the 3 products formed. Yes, I know B is going out, but B is not our required product. So let's start with P. So P is one of the product. And what is the name of the chemical name of P? P is chlorine gas. Okay, we said Q is also another product. And what is the chemical name of Q? It is hydrogen gas. Then our next product is D. D is a product. And what's the chemical name of D? D is sodium hydroxide. Okay, I need to tell you here that how is sodium hydroxide formed? This is what you have to know, that sodium ion is closed. It crossed the membrane. It's selectively chosen to go through the membrane. So you have the sodium ions. And you have also the hydroxide ion here. So when these two combine, what do we get? We get sodium hydroxide, which is this one. Yeah, then we come to this question. It says that give any two properties of each of the products formed. Okay. Yeah, we identified the products. The first one, we said it's chlorine as one of our products. So what are the properties of chlorine? We know. First of all, we know it's poisonous. Yeah, that one actually explains its use as a disinfectant. Okay, another use is bleaching property. Yes, it has the capacity to take out color. Okay, let's go to another product. It was hydrogen. Yes, what are the properties of hydrogen? It's a colorless gas. Okay. Secondly, it burns. Yeah, with pop sound. Here we have to know also that this is greenish yellow gas. Chlorine is greenish yellow gas. Actually, sometimes we use this property for its identification. Okay. Lastly, we have sodium hydroxide. Okay. So what are the properties of sodium hydroxide? The first one, it's alkaline in nature. It's alkaline in nature or basic. Yeah. Another property, it is corrosive in nature. It can cause peeling of skin and other materials. Yeah, then we come to this question. It says that give any two uses of each of the products from the cell above. Okay. Yeah, these are the products we have, the P, the Q, and T. And the question is, what are their uses? Let's start with P, which is chlorine. So what are the uses of chlorine? First one, it is used as disinfectant. It has the capacity to kill microorganisms. Secondly, it is used as bleach and many other uses. Okay, we can go to Q, which is hydrogen. Okay, so what are the uses of hydrogen? First of all, we can use it for welding. Hydrogen can mix with oxygen and burn at a very high temperature. And that flame, we use it for welding of metals. So welding. Secondly, we can use it to saturate fats, which we normally observe in the formation of margarine. Yes, during formation of margarine, plant oil is bombarded with hydrogen, which improves its saturation, and that one turns it into a solid. Another product is sodium hydroxide. And what are the uses of sodium hydroxide? The first one is formation of soap. Yeah, the process is called saponification. Yes, another use is we use it in manufacturing of paper. So manufacturing of papers. And with that, I would like to thank you for your time. The channel is PSSB with me, Richard, here. We urge you to subscribe, to comment, to like, to share. Yeah, we believe we are the best. See you next time. Bye-bye.